In this video, we're going to look at the question of why does 1/17 have a repeating decimal block of length, the prime number minus 1? Now, I should point out this is not the only prime number that does this. So if you do the decimal expansion for 1/7, the repeating block has length 6, which is 1 less. If you do 1/17, we'll see it has a repeating block of length 16. 1/19 will have a repeating block of length 18. 1/23 will have a repeating block of length 22. And 1/29 will have a repeating block of length 28. So in some sense, this isn't going to be a proof, but I'm going to kind of illustrate why it turns out that the longest possible block for 1 over a prime number, the repeating block is going to be, at most, the prime minus 1. All right, so let's do this division. We got 17 in the divisor and a whole bunch of zeros in the dividend. So 17 goes into 10. No, it doesn't go into 10. 17 goes into 100 5 times. 17 times 5 is 85. And we'll subtract that to get a 1/5, and then carry down the 0. I want you to notice as we go along, look at the different numbers here. Every time there is a different 3-digit or a 2-digit number here, a repeating cycle cannot happen. We would have to hit a 100 again or a 150 again for there to be any chance of a repeat. Okay, 17, let's see here. 17 times 8 is 136. Okay, that's going to be a 140. Okay, again, look at it. It's a different number. Every time we get a different 2 or a 3-digit number here, there's no chance of that next digit causing a repeat. 17 into 140, you're still going to get an 8 there. 17 times 8 is 136. Okay, we're going to subtract there, and we'll get a 40. Okay. Again, a different number. We have not hit a repeat yet, so we're not going to recycle the numbers yet. 17 goes into 40 twice. 40 minus 34 is 6. Carry the 0 down. Yet another number. Mathematically, we should expect, we kind of notice a pattern here. We should expect to run into a 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160 along the way until we get a repetition. So that's what's going to happen with all these multiples of 10. You're going to get multiples of 10 from 10 all the way up to 160 along the way. There will be 16 places in which we've got to add numbers up here. And the moment we hit 100 again, that cycle is just going to go all the way back through again with a 100 and a 150 and a 140 and a 40 and a 60 and so on. Once you start getting out here toward the 17th, the 18th, and so on digits. Okay, 17 times 3 is 51. 60 minus 51 is 90. So again, we got a new one here, the 90. Let's carry it up here. Let's more of these up here. Let's put it back in the original. Over there. 90. Okay, 17 times 5 is 85. Let's put an 85 there. That's going to be 90 minus 85 is going to be 5. And we carry down the 0. Again, look at the different multiple of 10 that we run into. 17 goes into 50 twice. 50 minus 34 is going to give us a 16. And we carry down a 0. So again, there's a different multiple of 10. See, 17 times 9 is 153, so we'll put a 9 up here. 17 times 9 is 153, and we'll subtract and we'll pull down 7, and then carry the 0. Again, a different number. 17 times 4 is 68. We'll put a 4 up here. 17 times 4, we're going to subtract that. We're going to do a 20. Again, different multiple of 10. Okay, then 17 to 20 is going to be a 1. We're going to subtract 20 minus 17 to get a 30. I'll line these up again. Okay, let's put the 3, 0. Hold on, let me erase that there. 3, 0. Let's put the orange circle again. A new multiple of 30 pops up. And 70 goes into 30 once. And subtract a 17 from that. 30 minus 17 is going to be a 13. And then we carry a 0 down. Another multiple. Another distinct multiple of 10 pops up. See, 17 times 7 is 119. So go into it with that quotient, and then the remainder is going to be an 11. 130 minus 19 is 11. Carry down the 0. Okay, we've got another distinct multiple of 10 that we haven't run into yet. 17 times 6 is 102. 17 times 6. Put the 102 there and subtract. So 110 minus 102, that's going to be an 8. And then we carry down the 0. So I'll run these up here. Again, a brand new distinct multiple of 10. And then let's see, 17 times 4 is 68. 80 minus 68, that's going to be a 12. Carry down the 0. Another distinct multiple of 10 pops up. All right, and then 17 goes into 127 times. Quotient. Then we get 120 minus 119, and that's going to give us a 1. And then back to 0. And this distinct multiple of 10 we've hit. 1, 2, 3, 4, 5, 6, 7. No, I already counted that. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 distinct multiples of 10. But 17 does not go evenly into 10. It's got a quotient of 0, remainder of 10. We carry another 0 down, and here's where the repetition starts. So let me have an orange closure there. And then when we hit the 100, then from here on out, we're going to be getting the 5, 8, 8, 2, 3, 5, 2, 9, 4, and so on forever, because we'll just go back through and have the 100 minus 85. We'll have the 150 minus 36. And the 140 minus 136. And the 40 minus 34, and so on, all over again. And that's what happens there, why we're able to, for some of these prime numbers. Not all of them. Not all prime numbers will do this. But for some prime numbers, the reciprocal will have a repeating decimal block of exactly length prime minus 1. Because you're going to hit every single one of these distinct multiples of 10. From 10 all the way up to 10 times the prime less 1. And then this thing cycles all throughout again. We start getting into the 17th, 18th, 19th, and so on places. So that's why 1/17 is going to have a repeating decimal block of length 17 minus 1. And why that's the maximum possible that we could have expected for 1/17.